Hey everybody, Mr. Stewart here, and welcome to a screencast on none other than the cosine law. So to follow up what we were doing in class, I know that you guys were trying to work out how to calculate using the formula, but I thought we would start this cast off with the conditions for using the cosine law. Okay, so the first set of conditions, okay, is known as SAS, which is otherwise side angle side. Okay, and more or less what that means is that you will be given a side, a contained angle. Okay, so let's call that a contained angle, followed by a side. Okay, so side, contained angle, side. Okay, and what is that useful for? Well, that can be used to calculate the length of the side across from the angle. So that is this side here. Okay, given that it's vertex B, this would be side B. Okay, the next situation is what we refer to as SSS, so this triple S, otherwise known as side, side, side. So this is where you're given 1, 2, 3, all sides, and what you're required to find is an angle. And in fact, you can find any of the angles with SSS. So these are the conditions strictly for cosine law. We have some that are for sine law, and then with right triangles we have SOHCAHTOA. So those are your three main strategies for working with solving for missing sides and angles in triangles. So let's give this a go with finding the length of a side. So let's have a look at this problem. So we have triangle ABC. It says it's oblique. Okay, so recall what that term means, oblique. It means non-right. Okay, it could have all acute angles, or it could be a triangle with at least one obtuse angle. And we have given information. We have an angle A, side B, and side C. And we're being asked to solve the triangle. So to solve meaning to figure out all of the missing information. So let's go ahead and sketch this thing out. I'm noticing that 111 degrees, that's obtuse. Okay, so let's start by tracing that out. So let's say that 111 would be roughly that size. And then from there, we'll label that as A. The other two sides are those that would contain, right? These sides here are going to contain that angle. So let's say that this will be vertex B, and that is a length of, actually we'll wait on that for a moment. This is vertex C. We'll complete our triangle. So side B would be right here, and that would be 74. Oops, 74, not degrees. Okay, let's change that here. Looks like we have a mix-up with our pens. Actually, you know what? Not looking very great, so start over again. That's a bit cleaner. There, that looks better. All right, things are labeled. So what we need to do is to figure out the missing side, which is opposite of angle A, and that's going to be side A. So based on some prior learning, we have a cosine law relationship. So we have a, okay, so a squared is going to be equal to the sum of the squares of the other sides minus 2 multiplied by b by c by the cosine of angle A. Okay. So we'll go ahead, we'll fill in that information. So A, of course, we do not know, but B is none other than 74. That gets squared along with the 29 minus the product of 2, 74, and then 29, and multiplied by the cosine of 111 degrees. Okay, so let's go ahead and let's evaluate our squares. So that's 74 squared. So 5476 plus the square of 29, 841. And then we'll figure out the product of 2, 74, and 29. For 292, so 4,200. Whoops, let's undo that change. So 4,292 multiplied by the cosine of 111 degrees. All right, let's keep on moving. Let's find the sum of the two squares. So 5,476 plus 841, that's a sum of 6,317 minus 4,292 cosine 111 degrees. All right, so let's see if we can't enter all of this into the calculator in one shot. So let's take that, let's subtract. I'm going to open up some brackets because I'm recognizing that this portion here, right, this is being multiplied. So I really want to make sure that I'm using the order of operations appropriately. And some calculators may or may not recognize that. So with an open bracket, I'll take 4,292 multiplied by, you can see I don't have a bracket up there. Let's try that again. 6,317 minus open bracket, there it is, 4,292 multiplied by the cosine of 111 close bracket equals 7,855. Okay, so what I'll do here, I'll just write approximately, and I'll take a few decimal places. But what I'm most interested in is the following. Okay, I'm thinking that I'm not going to take the square root of this, but rather I'd rather take the square root of what is on my calculator output right on the screen. So I'm going to go back and I'm going to take my square root right here. Okay, that's what I'm going to do. So you could keep this line here, that's fine, but I'm thinking what we'll do is I'm going to go from here right to there. So that's going to give me a value of A, okay, and then we'll round from there. So let's square root this thing, 88.6, and as far as precision is concerned, we are using whole number values, so let's round that up to 89. So it's about 89 in length. One thing we should do also is to make sure that makes sense. So A is about 89. Let's see. This is the largest angle. This is the longest side. So it does check out. Okay. So the only other thing that we need to deal with is finding a missing angle. Okay. So just checking in on our time, that's really important that we keep the cast to a reasonable length, and it's already at 9 minutes. So what I'm going to suggest, everybody, is we'll split this in two. Let's do a quick follow-up as to what we can do now. Okay, so let's take inventory of what we have. So we have all three sides and we have an angle. Okay, just because it's the cosine law section doesn't mean that we can't consider other laws. So what I would think, or have you think about, is let's transition into sine law. Okay, because I think we can do that. Because if we have A, right, if we have the sine of 111 and its corresponding side length is now roughly 89, that's going to be approximately equal to the ratio of, say, B as it is to 74. Okay, so you can end up cross multiplying and working your way through the sine law. Okay, so I'm going to leave that to you to finish off this portion of the solution. Bring that back into class. Bring the work with you. Bring any questions that you happen to have about how this was solved, and then we'll go from there. Okay, so stay tuned for part 2 of the cosine law.